This is a solution to the development question that was asked in the 2025 trial HSC, Independent Trial HSC. I'm going to do the solution in two ways. First of all, I'm going to use an auxiliary plane, which I've set out all of the lines here. These lines are a little bit heavier than they should be. These are construction lines for the video. So I'll do the auxiliary plane method here, and then I'll do the development by triangulation solution down here. So the first thing you do is to put a plane in that's parallel to the right side view, and then project these lines across to the plane and project them down here. Now, these lines here will be true length as far as the width of these points from one another. And these lines here will be the true length. These distances here will be the true length if we mark them along these lines here, which will be the true length at 90 degrees, and that will give us a true shape there. So put my compass on this distance here, and I mark from the plane, and that will be point A. And then from the plane again, mark along line B. Make sure you mark the point each time, because otherwise you'll get lost. C is directly on that line there, so that point there will be C, and D will be that distance there, and that will be D. Then it's a simple matter of firming in these lines here. To join two dots, it's best to put your pencil on one dot and then put the rule on the other. Makes it much easier and much faster to do that. And that's the development of the surface ABCD. The next way is using triangulation. And the two things that you've got to remember about using triangulation is that to determine whether a line is a true length, because all lines on a development have to be true length, you ask yourself, is this line a true length? You look in the other view and you see that if the line is parallel or to the, horizontal, or it's a point in the other view, this line will be a true length. So you can see that this line here in the other view is not horizontal and it is not a point, so therefore that's not a true length. So if we put our compass on AB here, we're actually getting the base length of the triangle, the imaginary triangle, so that if we set up a right angle, which we've already got set up here, if we put that length as the base, and we know how high A is above B, so that's how high A is above B there, we can work out the true length of that line AB, which will be the hypotenuse of the triangle. So let's start with, we'll start with point A here, and I'll just draw a line. So I'll get the true length of AB on that. So I put my compass on here, and I'm getting the true length of the base of the triangle, and I know how high. It's very close because it's a low angle, and I know how high A is above B, which is that distance there, and that distance there will be the true length, which is almost the same as that length there because it's such a low angle. So I just mark on that there, and that point there will be point B. Now I want to get from B to C, so I put my compass on BC here, and I know that that is not a true length because BC in the other view is not horizontal, nor is it a point. So I can see that B is that distance above C. So if I put my compass on here, there's the base length of the triangle, and then mark the hypotenuse. So that will be the distance from B to C. So you just put an arc out there, and then you go from A to C. AC is not a true length, and that is the height above, that's the height of A above C. So we put that as the base length and get our compass on there to get the length of the hypotenuse, and that will be the distance of A to C. So we just mark that around there, and that point there will be point C. Now, CD is a true length because it's horizontal in the other view, and so I can just put my compass point on D and get the length of C, and mark it out here somewhere, and then I go from A to D, get the true length of AD, mark it here, and that will be the true length of the hypotenuse. Then mark that there, and that will be point D. Then you firm in, and that's the true shape of the surface A, B, C, D.